Hey there, welcome to Chapter 7, where we are talking about similarities. We're using a lot of proportions to know that sides are similar or shapes are similar, sides are proportional, and the same thing goes for Lesson 7.4. So 7.4, we're going to talk about parallel lines. So those are those transversals that help us get more information from that. And then how do those parallel lines translate into our proportional parts? So remember, our proportions are two fractions that we set up, and then to solve we can cross multiply to create equivalent sides. So something we've kind of talked about before is a midsegment of a triangle. Before, we have talked about the midsegment of a trapezoid. So remember, the midsegment talks about a point that is in the middle of one of the different sides. Same thing goes with the triangle. If you notice, I have a midpoint, point J, and a midpoint, point K. That midsegment, JK, is going to be parallel to our side of our triangle that it is parallel to. So Theorem 7.5 talks about that midsegment. It talks about the parallel sides, all the things. So if a line is parallel to one side of a triangle, so notice that BC is parallel to CD, not necessarily the midpoints, but can be, and intersects the other two sides, so parallel intersects the other two sides, then it divides the sides into segments that are proportional lengths. So what does that mean? I like to look down here. So I know that these two sides are parallel, so I can then say that AB over BC is equal to AE over ED. So you could say A over B equals C over D. You can also say A over C is equal to B over D, however you like to kind of see that proportion being created. Just stay consistent with it. To solve for maybe a missing side length or a missing variable, you would just cross multiply. These two different proportions work just because I have just crisscrossed the just one part of the proportion. So that is why they stay equivalent either way. Alright, so we're going to find the side length of our first problem. We know that RT is parallel to VU, which would then allow to create a proportion. I'm given that I have 3, X, 8, and 12, so I need to find SU. I need to find X. So a few different ways you could set it up. The triangle proportionality theorem from above says that I would say 8 over 3 equals 12 over X. If you like that way, that's fine too. I like to put 8 over 12 equals 3 over X. I can visualize a little bit if I create a proportion out of kind of the top and the bottom. That's how I like to create my proportion. Again, either way will work. Cross multiply 8X is equal to 36. Divide both sides by 8. X is 4.5, which is also SU, which is what they asked for. Alright, if you will stop this video and check your progress, here is your answer. Alright, let's look at the converse. So remember, converse just means I say if P then Q for my original. So then the converse would mean if Q then P. So I'm just switching them around. So if my sides are proportional, then I can prove that the lines are parallel. So if I see that if I know that A over B equals C over D, then I can prove my lines are parallel. So we're proving lines are parallel in this converse. All right, flip the page. I'm going to look at the check your progress first. So I am given lengths of x, y is 15, yz is 25, WA is 18, and AZ is 32. With that information, I want to know, can I prove that this is parallel to this? So I'm just going to set up a proportion because I know if it is proportional, then I can prove lines are parallel. So I'm going to say 15 over 25. Does that equal 18 over 32? A couple different ways to say is it equal. You can reduce fractions if you like that. You can put them into a decimal if you like that way. So do 15 divided by 25 in your calculator. Does that equal 18 divided by 32? You can also cross multiply if you like to do that. So 25 times 18, does that equal 15 times 32? Either way, I just reduced my fractions. I said 9 over 16. Does that equal 3 over 5? And I can say, no, it is not equal or proportional. So if they're not proportional, then they are not parallel. They cannot be proven parallel. All right, so right up above, we're going to do one more. This has a little bit more of a step to it. So DH is 18 and HE is 36. DG is 1/2, and I'm going to call that X. GF, and GF I can just say is X. I want to determine, are these two sides parallel, and then explain. So I know that if my sides are proportional, then I can say that it is, they are parallel. So I'm just going to say, is 18 over 36 equal to 1/2 X over X? And that looks like a lot, but just keep going. Set up your proportion like you know, and then solve. Again, a couple different ways you can do it. You can reduce your fractions. You can cross multiply. So does 18x equal 1/2 times 36 is 18x? So that would say yes. You could reduce your fraction to say, does 18 over 36 equal 1/2? Because your x's would cancel. That would be 1/2 equals 1/2. So because those are equal, then I can prove that my lines are parallel. So GH would be parallel to FE. So that's your converse. Another thing we can use with the midsegments and parallel lines. So a midsegment of a triangle is parallel to one of the sides of the triangle, and its length is 1/2 the length of the side. So that's a fun extra little information that can help us solve. So if FG was 8, I could tell you that because JK is your midsegment and it's parallel, I could say that was 4. It's just half. So parallel, midsegments, half of some of those little concepts that you can put in your brain to help you solve problems. So in my picture, I know that I have 2 midsegments, and I'm trying to find AB. So AB is here. I'm going to find the midsegment that would be parallel first. That would be DE. DE is 5. So I know that my midsegment, if I take 2 times my midsegment DE, that's going to equal my whole side of my triangle. So I know that AB is equal to 10. I'm just going to double it. All right, same picture. Now I'm just trying to find FE. FE is here. So that is one of the mid segments. So the mid segment is always going to be smaller than the side of the triangle. So this is the side of the triangle that it would be parallel to. So that the parallel sides are what I'm going to use to compare. So FE, I'm going to double that to equal BC, which is my whole side. So if my whole side is 18, I know that FE would be half. So FE would equal 9. So the mid-segment will always be smaller. That's one way to check. Will always be smaller than your side length. And then last thing, because our mid-segments are parallel, I can look at that mid-segment and think, oh, well, that can create different types of congruent angles. So I'm looking at AFE angle, and then I want you to think about AB, since that is parallel to ED, and that green line that's creating our angle can kind of be that transversal. So if I'm looking at this angle, I know that those two green angles are alternate interiors, and because of the parallel lines, I know that alternate interior angles are congruent. So because FE is at D is 87, I know that the measure of angle AFE is also 87 degrees. All right, why don't you stop this video and do your 3 check your progresses on the back. Here are your answers for you to check. And then I would just make sure, just use logic. So if you're going too fast, because these are fairly basic things that you can do quickly, just make sure logically you're not saying that if I'm looking at DE and AC, if AC is 15, I'm not putting this as 30. Logically, that would be incorrect, and I've just kind of gone the reverse. So that's one way to keep it in mind. All right, proportional parts of our parallel line. So now I have 3 or more parallel lines. So notice the 3 parallel lines, 2 transversals that cut it. They cut the transversal proportionally. So I can say AB over EF equals BC over FG. I can also set up my proportion the way that they did. It will work either way, just keep it consistent. All right, in the figure I have 3 parallel lines, 2 transversals. I need to find X. I need to find the distance between my city blocks. So I have 3 parallel lines, which helps me create my proportion. So you can set it up as 26 over X is equal to 13 over 16. You could also say 26 over 13 is equal to X over 16. Either way would work. Cross multiply. 13x is equal to 416. So the distance between the 2 streets is going to be 32, we'll call it miles, maybe? That probably doesn't seem right, but we're just going to go with it. If you will stop your video and check your progress. There's your answer. And then last thing, congruent parts of our parallel lines. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off the congruent segments on every transversal. So notice my tick marks. So we are not proportional right now. We are using the tick marks. Tick marks mean congruence, right? So if one side is congruent, then I can assume that the other side is going to be congruent. We're almost out of time, so I'm going to kind of quickly fly through this. I see my tick marks here. I see 3 parallel lines. So I can say that 3x minus 7 is equal to x plus 5. Because one side is cut congruently, I can say that the other side is cut congruently. So 9y minus 2 is equal to 6y plus 4. Once you solve that, x is going to equal 6, looks like, and y is going to equal 2. If you will finish out this, you check your progress at the bottom. Here are your answers and your setup, and that is all I have for you for 7-4. Have a great day.